Okay, these notes are for the last section of Unit 3. So in this textbook, Chapter 4 is a very long chapter, and so we've broken it up into 2 different units. So this is the last section of Unit 3, and then we're going to stay in Chapter 4 of this textbook and continue on with Unit 4. So we're going to talk about reference angles, and reference angles are really important, and I've already been using them. I just haven't really referred to them such as reference angles. So what's important to understand about a reference angle is there's a few things that's important, but I can demonstrate it a lot easier than I can just explain it. So if I were to draw an angle in standard position, and I always have to include my XY axis. I don't care if you label them or not. And I'm just going to arbitrarily draw an angle. Here's the terminal side. So here's the angle. Remember, the arrow has to show direction. So this is my angle theta. I need a reference angle so that I can use right triangle trigonometry to solve for the trigonometric ratios. In order to do that, the angle has to be positive. It has to be acute. It has to be less than 90 degrees. And it always has to use a horizontal axis as a leg. So the way I think of this is I always want to go the positive direction, but making sure that I get to the closest x-axis. So my x-axis is along here, and it's along here. This is closer to this terminal side than this one. So I draw a positive angle, and I label that theta prime. And now I'll give you several different examples, and then during the live lesson I'll give you more examples as well. So if I start out with, say, 200 degrees, and I draw a 200 degree angle, and I don't care that it's exact, it just needs to be in the correct quadrant. This one is in quadrant 3. Well, I need to draw an angle that's positive. It has to have the x-axis as a leg, and it has to be acute. It's going to be this angle right here. So this will be theta prime, and this will be theta. And what's important about theta and theta prime is they have the same endpoint. So the trigonometric ratios are going to be the same. To calculate what this is, I'm going to do, this is 200 degrees. The closest distance is to the x-axis is subtract 180. So theta prime ends up being a positive 20 degrees. I'll give you another example. Let's make this one 305 degrees. So 305 degrees is going to be somewhere here in the 4th quadrant. So now I want to get to the x-axis. The closest x-axis is the positive x-axis, but it has to, the angle has to go in positive direction, so it's going to go in this direction. So this is my theta prime. That was theta. And I want to find the measurement of theta prime. So I've got 305 degrees, but this distance that I had to get to would have completed 360 degrees. So I take 360 degrees and subtract 305 degrees. And I get 55 degrees. So if you're looking for a formula, there's not a formula. You have to understand what you're doing. And I know some people look for the easiest way, and to me the easiest way is just to understand what you're doing. What if I had a negative angle? Well, negative 250 degrees, I know if I start here, negative 90, negative 180, and all the way back up here is negative 270, so it's not going to be quite to there. So there's my theta. To get to the closest x-axis, it's that one there. But now I have to think a little bit harder. It's not like I'm subtracting it from 360. I can't add 360. I guess I could use 180. but I have to be careful if I do it that way. So the way I usually try to explain it is negative 250 degrees is coterminal with 110 degrees. So this angle would be 110 degrees. But I want to get to 180 degrees. So if I take 180 degrees and subtract 110 degrees, that's where I get my reference angle, 70 degrees. And there's other ways to do this. I've just learned that when I explain it best this way. We're also going to do it with radian measure. And we haven't used radian measure in the last section, so it might take a little bit more time to get used to it again. So let's use the angle 3 pi over 4. So once again, I think of this as all the way across is going to be pi, so I have to go 3/4 of the way. So there's my theta. I want to get to the x-axis. So we go in this direction. This is my theta prime. I forgot to mark it on this one. So if I went from 3 pi over 4 to get to pi, what I did was pi minus 3 pi over 4. Get a common denominator. 4 minus 3 is 1. So my theta prime would be 1 pi over 4. Okay, the reason you need to understand reference angles is because we're going to look at angles, and we're going to have to create a triangle in order to evaluate the 6 trigonometric functions. So this process takes a little bit of getting used to. So I'm going to start out with saying I have a point on a terminal side of an angle. And for my example, I'm going to use the point -6, -5. So the first thing I want to do is plot the point in the coordinate plane. And I'm actually going to put the tick marks on here. So -6 left 6 down 5 is about here. I have to draw that as the terminal side of an angle. So basically what's happening is this would be the terminal side of the angle that goes all the way across here. And so my angle would be that angle there. And I don't need to extend this past that point. I just try to show you, give you a reason for that. And so you have to make sure when you draw the terminal side of the angle, you use the origin. If you don't use the origin, you're not drawing it correctly. Then we're going to draw and label a reference triangle. That's why we needed the reference angles. So if this is my point, I'm going to go to the x-axis. And there's my triangle right there. So my right angle is right there. I need to label my reference triangle. So since I went left 6, this is going to be -6. I went down 5, this is going to be -5. It's important. You must label it in the correct way with positives and negatives. My theta prime is what's in here. So now I need to find the hypotenuse. And I'm going to use Pythagorean theorem. I know -6 squared plus -5 squared is equal to c squared. C squared is going to equal 61. Therefore, c is going to equal the square root of 61. And notice I'm not putting plus or minus here because the hypotenuse does not have a direction. Left and right is a direction, up and down is a direction. Hypotenuse is not going to have a direction. So it's just the square root of 61. I'm going to label that over here. Then I can actually find my 6 trigonometric ratios. So the first one I'm going to find, I always find sine first. So sine of theta is the same thing as sine of theta prime. It's going to be opposite over hypotenuse. And rationalize the denominator. Cosine of theta is adjacent over hypotenuse. Rationalize the denominator. Tangent of theta is the opposite over adjacent, and always reduce your fractions. Negative over negative is going to be a positive. Once I do those three, I can easily figure out my cosecant, secant, and cotangent. So the cosecant is just the reciprocal of the sine. So I'm not going to go back to the one that I've rationalized. I'm going to look here at my first one that I wrote down. So I have negative square root of 61 over 5. My secant is my reciprocal of cosine. So negative square root of 61 over 6. And my cotangent is going to be my reciprocal of tangent. And there is a way to check this. You could actually calculate the angle and then go back and check all these with the calculator. I like to do that just to make sure I did it right, but you do not have to. So this section is new for you. Everything in this is new. So if you have questions, please ask. I'll give you many examples and we will practice this.